All right, let's attack this dude. 4.2, we're going to graph some rational functions. These are the guidelines that the book gives us. They're really good, but man, are they so wordy. Let me simplify this for us. Bam! Steps simplified. All right, check it out. The first thing you're going to do is you're going to find the Y-intercepts. Next, you're going to find the X-intercepts, then your vertical asymptote, horizontal asymptote. Then, after you find those four main things, symmetry, extra points, and then connecting your dots with curvy lines, this is how we're going to graph rational functions. Now, let me get a little bit more specific right here. When we're finding a Y-intercept, what you're doing is you're plugging 0 into your function. So if that's your function, you're just going to plug 0 into all the x's. And then for the X-intercepts, that's the same as 0. So that's taking your function and setting that equal to 0. So I guess in this case, if this was my function right here, I would be setting nx over d of x equal to 0. But really, the denominator doesn't matter in this scenario because you can multiply both sides by the denominator. So, in actuality, you're just taking the numerator and setting that equal to 0. That's how you're going to find your zeros or your x-intercepts for your rational function. And then your vertical asymptotes, that's taking the denominator and setting that equal to 0 because you're trying to find out which values of x would make the denominator 0. We know that the denominator cannot equal 0 because you can never divide by 0. So that's what we're doing right there. And then horizontal asymptotes, that's when you're doing the degree test. Remember we talked about that earlier. You're checking the degrees of the numerator and the denominator and deciding what your horizontal asymptote is going to be. Your horizontal asymptote is either going to be the leading coefficients, where you divide them. That's if the degrees are equal, or your horizontal asymptote is just going to be y equals 0 if you have a degree on the numerator that is less than the degree on the denominator. If the numerator's degree is greater than the degree of the denominator, then that means you don't have a horizontal asymptote. You have a slant asymptote. But most of the time, we're going to have horizontal asymptotes. For symmetry, that's the negative x test. That's when you plug in negative x to see if you have symmetry about the y-axis, or if you have symmetry about the origin. Okay, it's the y-axis if you get exactly the same thing after you simplify. So if you plug in negative x, you get exactly the same thing, then you have symmetry about the y-axis. If you plug in negative x and you get exactly the opposite function, meaning all the signs are different, that means you have symmetry about the origin. And let me give you a clue in when this matters. Let's say you have a function and you got this side right here. All right, you got an asymptote right here, you got an asymptote right here, and you do a symmetry test. You find out that you have symmetry about the origin. That means you're going to kind of reflect diagonally the other line that you've already drawn. Let's say you plugged in a negative x and you found out that you plug in negative x and you get the same exact thing. That means we have y-axis of symmetry. That means your line would look like this. Now this is a little too pointy for me. You got to try to make your lines very curvy. Is it possible that that a line can go like this? Yeah, and the only way you can know if it makes a sharp turn like that is by picking points and plugging them in. But anyways, that's when symmetry comes into play. Let's look at the rest of it here. Next is extra points. When you do extra points, what you want to do is you want to pick points on, like let's say we have two vertical asymptotes. You want to pick a point in this area and pick a point in this area and pick a point in this area. So you got to pick a point in every region wherever the horizontal asymptote or vertical asymptotes are. Let's say you only have one vertical asymptote. That means you got to pick a point in this region and a point in this region. That's what extra points means. That way you know where the lines or where the curves are going to go. The last thing is, make it curvy. That's just kind of more like a reminder. Now I could take this and simplify it even more. Bam! All right, here we got intercepts, goes right there. We have our asymptotes right here. And the extra points, I'm including the symmetry and extra points in the extra points. And then you have curvy, just to remind yourself to make sure you got curves. Now, extra points includes the negative x test, so you can use symmetry. Sometimes I do extra points before symmetry. That way symmetry matters to me, because then I don't have to test even more points. But sometimes you don't even need symmetry. But I don't know. Sometimes symmetry is just really easy to use, and so then you would use it. All right, let's get on with the program, and let me show you guys the first example.